Hey, what's up everyone? Welcome to Descriptive Chem / Lab Part 2, and today is all about colors. So we're going to look at flame test colors and colors of solutions, starting with flame test colors. So when you put a compound containing a certain metal ion over a flame, a characteristic color is given off. So a easy way to determine whether or not you have something like lithium in an unknown compound is if you put it over a flame, you're going to get a certain color. So in the case of lithium, you have this bright red color. And then NaCl, you have your yellow. And then potassium, you have your like purplish. And really, there's just a bunch of colors. Like copper is green. These are the actual colors, if you're wondering. And these have really interesting applications in like fireworks. So if you've ever been to a fireworks show and you wonder how they get those blue colors, those yellow colors, those green colors, chances are the yellows are like the sodiums, the greens are the copper, and these flame test colors are what give fireworks its vibrant colors. And like I mentioned, these flame test colors are also used to identify unknown compounds. So if you have a compound and you put it over a flame and it gives off a characteristic color, then you know a certain metal ion is going to be in it. And so let's do some practice. I'm going to leave the table up because I guess in order to memorize them, I think the best way to memorize them is just doing practice with them. Okay, so a solution of which compound gives a violet flame test? From the choices here, we have lithium, sodium, potassium, and boron. And an interesting thing about these is that it does not matter what your other ones are. So if you have LiBr, the only thing that's going to determine the color is the lithium. The bromine has nothing to do with it. Same thing with NaCl. The sodium is the only one that's going to produce a color. So let's look at the color that these produce. Lithium is going to produce a magenta to whatever that says color, and that's not like violet, that's not like purple. Sodium is going to be like yellow, and so that can't be it. Potassium is going to be, according to this, it's going to be a lilac to red, and that can be considered a violet flame test. So you might see different wording for some of these tables, but you got to kind of imagine the color. So potassium nitrate could be the answer, but let's take a look at boron to completely make sure. Boron is a bright green, and that is not violet, and so the answer that we're going with here is C, and we are correct. Let's do the next one. A solution of a salt of which metal produces a bright red color in a flame test? Firstly, we have lithium, which is a magenta to carmine. If you saw the this chart right here, then lithium does look a lot like red, and so that could be the answer. But let's look at the rest. Sodium is going to be intense yellow. Potassium is going to be lilac to red, like we saw, and that's more purplish than really red. And copper is going to be green. So the only answer that makes sense is lithium, and we are correct. Next is a national question. Which ion gives a green flame test? So let's go through it. Potassium, again, that's not going to be it. Potassium produces lilac to red. Calcium produces orange to red. That's not it. Strontium is crimson, but crimson is not green. And the only one left is barium. And barium is pale yellowish green. And that is the closest to a green flame test that we have here. So barium is the right answer. So I hope you learn how to use like the table, and hopefully you have some of these memorized by now. But if not, just do a bit more practice. I'm sure you can find some way to practice online. And within a few tries, you'll probably know most of the common colors. Let's take a look at the color of, oh, by the way, we're right. Let's take a look at the color of solutions. And so a solution in which the solute is a transition metal may be colored. So you can see a bunch of these here. We have titanium, vanadium, chromium, etc. And these are colored solutions. And not only does it matter what element you have in there, it matters what the charge of that transition metal is. If you're wondering why this happens, why it becomes colored, an explanation for this, or a theory for this, is explained using crystal field theory. Crystal, which honestly sounds like it should be a Netflix movie. Um, and I should have a video about explaining that coming up tomorrow. But it's a I think the topics that we have covered so far aren't enough to explain what crystal field theory is. But if you are wondering, it has something to do with your atomic orbitals. But yeah, for now, I guess this really colorful diagram is gonna have to do. Let's take a look at some of these examples. Which salt dissolved in water? Which salt dissolves in water to give a pink solution? So first of all, similar to the flame test colors, what really matter are the transition metals. So we're gonna have cobalt and copper, and then iron, and then zinc. So let's take a look at what colors these can form. The cobalt here produces a pink solution. So that is completely in the realm of possibility for the answer. Copper here, um, copper here produces like a blue, so that can't be it. Iron, Fe, is like greenish, yellowish. It can't be right. And then zinc. Zinc is not on this table, on this chart. And you can assume that if it's not on the chart, then it's going to be colorless. So zinc is not correct either. And the only one that makes sense is cobalt. Answer choice A. And we are correct. Let's take a look at the next one. Which compound will form the most intensely colored 0.01 molar aqueous solution? If you take a look at the answer choices, you'll realize the only one in which there's a transition metal that's going to be colored, the only one with one of those is going to be A, which is KMnO4. Chloride isn't a transition metal, potassium isn't, aluminum is a transition metal, but it's not colored, and then potassium and iodine are not transition metals. And so it must be A, because the rest are going to be uncolored. They're going to be colorless. And we are correct. If you were wondering specifically what type of color it's going to be, we would have to look at the oxidation numbers. So Kmn, or rather the charges. So an oxygen is going to have a -2 charge, so that's going to be a -8 charge. The potassium is a +1 charge. And since this entire compound must have a net charge of 0, then that means the charge of the Mn, the magnesium, has to be +7. And so we know a +7 manganese is going to have this kind of color, this like bright pink color. So if you're wondering how to determine the color, like specifically using the charges, that's how you do it. Let's take a look at the next one. Which cation forms a colorless aqueous solution? So remember, whatever transition metal is not on this chart, it's going to be colorless. So we have cobalt 2 plus. Cobalt 2 plus is right on here, so that's going to be colored. Nickel 2 plus is right here. It's going to be colored. Copper 2 plus right here. It's going to be colored. And then zinc. Zinc is not on here, so it must be D. And we are correct. All right, we have a few more. Each of the following forms a colored aqueous solution except, so we have chromium, Cr, and then cobalt, copper, and then zinc. So chromium has colors. Copper has colors. Sorry, that's cobalt. But cobalt also has colors. Copper has colors that we saw right there. Zinc does not have colors. Zinc is colorless. And so the only colorless solution is going to be the zinc, which is D. We are correct. Which dissolves to give a blue solution? So again, let's go through the choices. We have Na2S2O4, and that's going to be uncolored because it's not on this chart. We have K2CrO4. We have chromium, and none of the ions of chromium are going to be blue colored. So that's not going to be correct. Then we have copper. Copper actually does have a blue solution, so we can leave that there. And zinc again, I feel like zinc gets bullied because it's always colorless, and they just put that there every time. So zinc cannot be it. And the only answer that makes sense is C. And we are correct. Next, when a solution of barium hydroxide is mixed with a solution of iron 3 chloride, what is observed? Okay, so let's go through the chemical equation of this. So we know barium hydroxide is mixed with iron chloride. And so this is going to be your typical double displacement reaction. And we went over those last class if you don't know how to do them. So we're going to have barium chloride plus iron hydroxide. And barium chloride is going to be aqueous. But FeOH3, if you look at your solubility rules, it's going to be a solid, meaning we do see a precipitate forming. And not only is it a precipitate, it's a colored precipitate. If you look at iron right here, it's colored. And so we are going to have a precipitation of a colored solid. And that is the answer. Last one. Okay. Mixing which zero point 0.1 molar aqueous solutions results in formation of a colored precipitate. So right off the bat, we can cancel out A and B because there are no transition metals in any of the chemical formulas, and therefore there's no possibility for it to be colored. And so the only possibilities that we're left with are copper chloride and NH3COOH, and copper chloride and sodium carbonate. Let's take a look at C. So we have CuCl2 and acetic acid, CH3COOH, and that is going to form CuCH3COO plus HCl, hydrochloric acid. I think it's blocking it. Okay. And we know all acetates are going to be aqueous, so that's aqueous, and hydrochloric acid is aqueous. So we don't see a formation of a precipitate, and that means C cannot be the right answer. Therefore, D has to be the right answer, but let's take a look at why. So we have CuCl2 and Na2CO3. We do the double displacement reaction, see what happens. So we have copper carbonate plus NaCl. All carbonates are going to be insoluble other than potassium, sodium, and NH4. And so this has to be a solid, and NaCl is going to be aqueous. And so we do see a formation of a precipitate, but is it colored? It is going to be colored because we have that copper in there, that copper 2+, and that means that we're going to have a blue solution. And therefore, D is the right answer, and we are correct. That's all I have for this lesson. I hope you learned something. Again, if you want to know why we have colors of solutions, I have a video coming up on that. Anyways, I hope to see you in part 3, and I'll see you guys later.